I'm gonna explain you some keyword or terminology of the decision tree. So impurity is so what is impurity? Impurity is the chain of being incorrect that we randomly assign a label to an example in the same set, as you can see. The low impurity means that there is only one type of data, and the high impurity means that there are many missing type of data in a more simple set. And the second keyword is entropy. Entropy is a measure of messiness of your data collection. The messier or more random your data, the higher entropy will be. And the third one, I'm going to talk about what is information gain. Information gain is a decrease in entropy by splitting the data set based on some condition, and CAT stands for classification and regression tree. Here is my sample data that I'm going to build the decision tree and how that decision tree work. I hit some data set that we have like some feature like color, diameter, and the label. And our goal, we want to build a decision tree classification using the CAT algorithm to classify the data set. So there are three steps that we can do in order to make our decision tree effectively. For the first thing that we can do, we need to, determine the question that we can ask. So here is the list of some possible possible question that we can ask in order to make our decision tree. Like, is the color green, or is the diameter is greater or equal 3, or is the color of the fruit is red, or color is yellow. So how can we know which question that we can answer? In order to do that, we can look at the step 2. So in order to that, we need to find the average of impurity in our data set. By using the formula, the impurity equal to 1 minus the total sum of the probability of the sample that belong to the class E square. By using this formula, we can calculate the impurity of our sample data set. After we ask the one of our possibility question, we get the impurity because there are 4 set of data in here by applying the formula, and this is the only one set data, so the impurity is equal to 0. After that, we want to find the average of impurity. So by using the formula, we got our average of impurity is 0.5. And here is our step 2. So in order to choose the first question to ask, we need to make sure that what question have reduced the entropy the most. So the question that asked that is diameter greater or equal 3 is also reduce a lot of entropy, and it has 0.37 information gain equal to the question. So we can ask which one of them to be our first question after the rule now. So and follow that, we can add the question. So here is our final building of the decision tree. We add the question first, and we get like 2 apple and 1 lemon. After that, we add the question because this is the third entropy deduction. So after we ask all the questions, we can predict what we get in our simple data set. Here, as you can see, we have 1 apple and 1 lemon, so we can predict that there is a 50% chance in our class there are an apple and a lemon, and here it's 100% apple, so we can predict that easily. So let's move on to my friend for the random forest part. Thank you.
Now let's move on the random forest part. Now I'm going to explain you about the definition of random forest. Random forest is a supervised learning algorithm. It is an assemblage classified that using many decision tree model and usually trained with the backing method. And for the general idea of the backing method is that combination of learning model increase overall result. Random forests are about having multiple trees or like a forest of trees. Those trees can all the same type or algorithm, or the forest can be made up of the mixture of tree types. And for overall fitting and understanding can be used for the classification and decision. For accuracy or variable that is important, is provide with the result. Random forest flowchart, it start from the begin. It will check the input, and if the input is error, it will go to calculate predict error, or if not, it will continue us to for each tree, and then it will check again, and it go to end or continue to those training data subset. For the next, it will check the question that stock condition hold at each node, or if the answer is yes, it go to calculate predict error, or no, it will build the next bit. At the end, it works as loop until it ends. Next slide. For random forest algorithm, how does the algorithm of random forest work? The algorithm of random forest, it works by 4 steps, like you can see in the picture. For step 1, it pick a random sample for the input data set. And step 2, generate the decision tree for each sample and compute prediction result for each decision tree. Like the tree that we can see in the red box, we have tree 1, tree 2, 2, 3, and for the step 3, calculate vote for each predicted result. Like in the picture, we got 2 for class A and 1 for class B. The last step, it choose the prediction result that having maximum vote as a final prediction. So the final prediction is class A. Let's move to the next slide. My teammate will continue present about it.
Hello, teacher. I can talk about why I use the random forest algorithm. We use the random forest algorithm because it can be used for both classification as well as a regression test. It can overfitting problem that is same series and can be make result. The random forest, the classifier will not overfit, will not enough tree. And third is can be handle missing value. And the last one is can be used for category cost value as well. And next slide, advantage and disadvantage. For advantage, the first one is land predictive. If you like decision tree, random forest are like decision tree. On those random forest predictive capacity and make it useful. And third, no normalization. Random forest also does then require no normalization. And third is the data preparation. Overall, no requirement for normal normalization or scoring make random forest much more convenient. And for missing data, it's just like decision tree random forest handle missing value like a chain. And five, fast training. Training process is relatively faster for decision tree compared to some other algorithms such as random forest. And six, optimization option. Random forest offer a lot of parameters to try and improve your machine learning model. And when the data for light data, if you have light data or a large data set, you need to work on the very usually random forest algorithm handle large data set pretty well. And the last one, sophistication of output. Random forest also provide a really nice and sophisticated output with value important. For disadvantage. The first one, overfitting rate, also much lower than decision tree. Overfitting is still a risk with random forest and something you should monitor and can limit in regression. Random forest regression is a thing, however, with many regression model opportunity out. And third parameter complexity. Parameter complexity does not really compare to a test like manually writing a random forest algorithm. And for best toward available with a more level. If your data has categorical value with different level of attribute, it can be a big problem. The last one, track max situation. We cannot use this name random forest and manage it value as your product or a part of product without official permission from the owner, authority, or the trademark. That's all for this part. And next slide. Random forest with decision tree. For random forest, have provide that by generating more tree on a random subset and complete, not easy to explain. For decision tree, for a decision tree is a faster throughput by overfitting and is explained and can be converted to constraint rule. That's all for my part and move to the presenter. Thank you.
Now let me look at the example. We will use a training data similar to the one below. For example, note age, global weight, gender, smoking, age 98, age 99, and all the independent variable, or we can say that is feature. So we have 7 steps for the training set. Now let me look at step 1. It's gonna be talk about bootstrapping that refer to process or randomly choose the record. We provide the training data to the random forest classifier model. It's like a band or row randomly record that have already selected. It will be the data set for create the first mini tree. So let me go to step 2. For step 2, we we will select feature for step 3. We will choose the feature for the mini decision tree, random forest, select a subset of feature or column. Here is for set our simplicity, and for the example, we are choosing 3 random feature. Now let me go to step 3. Select root node. One the 3 random feature and select. In our example, the algorithm ran a splitting out the M record. And we calculate out the before and after value automatic, which table out the random feature, speed skill the less combined Gini impurity or entropy value. Global feature is select as the root node. The record and split at this root put based on the base splitting point. So let me go to step 4. Selecting the channel, the algorithm performs the same process as in step 2 and step 4, and select under set our 3 random feature. 3 is the number we have specified. We can choose what we like or leave it to algorithm to choose the best number. Based on Citeric, Gini, or entropy, it select which feature will go into the next node or channel, and for the splitting out the record happen here. So next we go to next step. For the next step is create more mini decision tree. This is the second mini tree that we create using another set out randomly, choose row or column. Note the mini tree will have a different from the first one if we have chosen the hyperparameter carefully. So next we go to the final step. For our final step is talk about be the forest or tree. one the default value of 103 is 3, and we now have 100 mini decision tree. We keep within the mini tree. Here we have n3. N is the number specified by an estimator hyperparameter. It has a default value of 100. If we don't specify anything, here the below box represents the end node. And also we have the rule like import learn dot in symbol dot random forest classifier. My OS equal random forest classifier and estimator equal 300. That's all for the example. So now let's go to conclusion. From all above, we can say that random forest is a supervised machine learning algorithm that is used widely in classification and regression problems. It's gonna be a decision tree on different sample and take their majority both for classification and average in case of regression. Thank you for your pay attention.
Thank you, teacher. That's all for our team.
Okay, thank you for the presentation. And anyone, do you have question? Feel free to ask your team or your friend. Okay. Anyone have a question? Antoine, do you have a question?
No, I don't have.
Okay, so let's go to the slide on the decision tree algorithm. I want to know how can you select the root node, the best root node, based on your impurity calculation or the entropy or the information gain.
Thank you, teacher, for the. Hello, teacher. Can you hear me well?
Yeah.
We can choose the root node by using the formula. We need to add like one of our possible, like in the same one we have like there are like possible question that we can add, but in order to add the first, which one we can add first, we need to find the average of our average of the impurity. In that, after we found the average of impurity, using the information, we know that the question that use a lot of info or that have a lot of information again, it could be a word root node because we use a lot of entropy. So we make after we split, we add the question. If we make a word data like have a low root node again. So the two questions became either one of them, or is the polar red and is the dimensional or delta or equality.
So if you said that it is based on the question you might ask. So in your example, you have only two features, which is the color and diameter. So if I have like multiple features, so how many questions should I ask? Or how many questions should I calculate to find the impurity and the information gain to select the root node or the best split?
I think we should try to calculate all the information gain. That it's the only way that we can find which one is have a lot of information gain.
So how many times do you have to calculate the information gain? Based on what?
Based on the possible questions.
So how can you determine the possible question in your data set? Only 4?
No, it could be more than that if we want to ask another question.
Excuse me again, please.
I think that could be more than 4. We can ask or greater than 3, not equal, or even though we can ask like equal 3. can be more than this.
Okay, thank you for your answer. However, I think this is a little bit confused. I think in your algorithm, they calculate the information gain based on the feature, not on the question. For example, you have to calculate the information gain on the feature color or the feature diameter and see if which one having the most, let's say like the information gain of color is bigger than the information gain of the diameter. So it is likely that the color feature would be the root node or would be the best fit for your decision tree, right?
Yeah, teacher.
Yeah, if you calculate based on the question, I think you have to determine how many questions should you ask, or may should you determine the question. I mean, so it might be difficult to find that. And okay, this is how you have to present the algorithm. So any other friend having question about the algorithm? No? Okay, so I have one more question. For the decision forest, random forest, sorry. So what is the result from each tree in the decision forest? And how you build a tree in the forest? Hello?
Sina and Nadika, can you answer it?
Or the how we build a tree in the forest, we build it by four steps like this line, and then we pick the rank. The can step is decision trees and compute for the predict result for each decision tree, and step three is calculate and uh, for the uh, for the predict this for the to find the result and choose the predict result that we have maximum vote as a final prediction. That's all.
So which means that from each result, I mean each result of each decision tree, there will be a predicted class, right? And from those three, you will using the maximum voting or maybe the weighted average to see if the majority of the class predicted. So your result from the forest gonna be the class with having the majority of the predicted class from the decision tree, right?
Yes, teacher.
Okay, you will find more when you do the research by yourself. So I believe everyone gonna have like a little bit idea on how decision tree work and also the random forest. And if you have question, you can ask your friend. It is just like how we learn together. Okay, just like that, because it's like you gather the information first and then you try to share what you know to your friend. Okay, so thank you for the first presentation, and let's move to the second presentation.
អត់ទល់គ្រូក្រុមពួកខ្ញុំគ្រប់ទី3តែគាត់ទី4គាត់ប្រេសិនមុនគ្រូ
អត់ស្ទើរយល់ម្ដងទៀតបានទេ
sorry តែច្រឡំ order ដល់ពួកខ្ញុំឃើញគ្រប់ទី
ក្រុមពួកខ្ញុំ linear regression មុនគ្រូដល់ពេលឲ្យគាត់ present មុន
អូខេខ្ញុំគិតថាដូចជាអីដែរឥឡូវយើង start linear regression មកចឹងអត់ទេ
ខ្ញុំមើលមុនឃើញគ្រប់ខ្ញុំតែ3លោកគ្រូdecision tree and random forest ខ្ញុំអត់បានចូលមើលគីឡូលោកគ្រូមាន update ទេខ្លួន
ខ្ញុំដូចជាអត់ update ទេតែដូចជាបញ្ហាហ្នឹងគ្រាន់តែ order ត្រូវអត់
បានគ្រូអីទេគាត់ថាគាត់មុនក៏បានដែរព្រោះឡំសមាជិកក្រុមគាត់បន្តមកពេញឥឡូវគាត់មកពេញអស់ហើយគ្រូ
អញ្ចឹងហ៎
បាទគ្រូ
អូខេ
អីចឹងខ្ញុំបិទ share screen ចឹងគ្រូអរគុណចឹង
Yes thank you
So let me share screen then for linear regression group.
អត់លឿនមកទៅ Betul Bu, misi di mana Bu?
Yeah.
Me, Lynn Madeline, Honpanet, some
Betul itu selain video.
Yeah, we hear the sound from the video.
Play.
Soban Suki, Sokwanan, and Songselasa. And today we are going to present about the simple and multiple linear regression. Here is the content of the day that we are going to present for all of you to listen. We have 6 part beside, and each part will be presented by each member who will respond with it. And the next part will be presented by Sokwanan.
So thank you, Marilyn, for that. So now let's move to my part. I will give you the general explanation of what linear regression is. So by the definition, linear regression is a statistical way of measuring the relationship between variables. So for example, like you have two variables, like one is time and one is cost. So if the time increase, the cost also increase. That's the relationship between these two variables. So as you can see in this graph, if the time change, the cost also change. So by using this linear regression, we can predict the futures. And for example, like if we want to predict the house price, given the square footage of the homes, and the average square footage value is, for example, $236. So if we were to graph this, it look like something like this, as you can see here. And as the result that we get from this graph, like 1,000 square foot home equal to $236,000. So if we want to predict another cost, we can just simply look at the graph. Like if you want to know how much it is for 2005 square foot. So if you look at the graph, you will see that it is equal to $433,180. So now let's look at the math behind linear regression together. So the formula is quite simple. It is just y equal mx plus b, where y is what we are trying to predict. M is a slope, or like in this example, it is 236 square footage. And x is the input, the value that we don't know. So if we look at this example, that previous example, it is equal to 1,000 and 2005. And b is the bias. So now let's implement this with our previous example, the house price example. So we have y equal mx plus b, where y is the housing price, m is equal to 236 average, x is the square footage that we have to input, and b here is 0 because there's no bias in here. So if we plug in the value of our earlier example, it will look something like this. Y equal to 236 multiplied by 2005 plus 0, and will equal to 433,180. And that is the general definition of linear regressions. And for the next part is the type of linear regression. So based on what I researched, I found that in total there are two types. First one is simple linear regression, and the second one is multiple linear regression. So for the further explanation of these two types, my teammate will do the presentation about it and start with the simple linear regression. Will explain by Suwansuki. Thank you.
So thanks, Shivana, for your presentation. Now, let's move to my part. So hello, teacher, and hello, everyone. My name is Swansuki. I'm going to presentation on my point talking about the simple linear regression. So what is simple linear regression? Simple linear regression is for the regression that we use for determine the relation or estimate the relation between two quantitative variables, which means that we have two variables that one is for the dependent and one is independent value. So those two variables, we have to determine that they have relation between each other or not. So in order to define our simple linear regression and also the relation between those two data of the dependent and independent value, we have our algorithm as well as the equation. So in order to determine the our simple linear regression, we have a equation that is equal to alpha plus beta h. And as you can see that there will be some any of the undenying relation of the involving error term that can be described on the equal to alpha plus beta h plus the exponential. For here exponential is for the error can be occur during the error term that can be described. So here, when we want to define our beta, we have our equation, which is or equal multiplied with s equal on the s is for the s equal is the sum of the equal minus equal min equal square on the divide with the data set minus 1, then square root. And for the sh is the same, but for the sum of the h minus with the mean of the h square and divide on the number of the data set plus minus 1 and square root. Then after we got our s equal to sh, we go into define our coefficient that can be between those two relation of the dependent and independent. So for the coefficient, we have our equation that the sum of the h minus the mean h and the multiple with the y minus mean of y and divide on the sum of the minus h minus mean of h and square. Then after that, we can be define our beta already. So we can define our alpha by the our equation of the top equation here. So in order to understand about simple linear regression, I have one example, which is the topic research or paper research talking about the prediction of the death using the simple linear regression, and it's from the Department of Statistics of Malaysia. So here we can see that the equation of the simple linear regression is equal to alpha plus beta h, and for the h is for the independent value is for the population estimate from the Department of Statistics Malaysia, and for the y is for Department of for the dependent value for the number of the dead. So after that, they merge those data into two steps. One is for one step ahead, and another one is 1, 2, and 3 steps ahead. Then after that, they got the three type of data. One is for long, one is moderate, and another one is short. Then they can define the error that can be occur, which is the for equal t is for the observation value t, and for the equal t hat is for the fit value time that generate in the origin. For the n is the number of the period sum or the data set. Then we got our data after the calculation and also of the prediction as well as the error. Then we got our data set over here. After that, they build a graph, and to define that the blue line is for the actual number that can be occur, and for the pink line is for the prediction that using the linear regression in order to define that those data have relation with each other or not. So thank you for your paying attention. Listen to my presentation. So let's move to the next part.
Thank you, Sukia. So now that we know what single linear regression is, let's move to the next point, which is about multiple linear regression. First of all, let's look at the definition. Multiple linear regression is referred to a statistic technique that is used to predict the outcome of a variable based on the value of two or more variables. The variable that is used as input is called independent variable because their value doesn't depend on anything. And the output variable is called dependent variable because its value is dependent on the input value. Let's look at this picture below. As we can see, the variable on the left, which is independent variable, determines the value of the variable on the right, which is dependent variable. The next slide is about formula of multiple linear regression. The formula is y equals b0 plus b1 plus plus bn plus epsilon, where y is the dependent variable, b0 is the y-intercept, x is the independent variable, bn is the slope coefficient for each variable, and epsilon is the model error because the value of because we can never get the exact value of y, so there is some small error, so we plus epsilon at the end. Now let's look at an example of multiple linear regression. Let's say that we want to determine the percentage of people that have head disease. We also gather the percentage of people who have smoked and the percentage of people who bike to work to see how this factor affect heart disease. We also go to 3 different towns to get three different results. Because we have 2 independent variables, which is smoking and riding bike, and 1 dependent variable, which is heart disease, we can use multiple linear regression to analyze the relationship between them. Let's look at the result with this graph. The x-axis refers to percentage of people who bike to work, and y-axis refers to people who have heart disease. The 3 lines refer to 3 different towns that have 3 different percentage of smokers. Just from looking at this graph, we can tell that as there is more people bike to work, there will be less chance of heart disease. And the chance is also lower when there is less percentage of people who smoke. So that's all for my point. The next part will be presented by Panet. Thank you.
Hello teacher, hello everyone, my name is Panet. I present on part how the difference between simple linear and multiple linear. For simple linear, we try to find benefit of the line. We need to find the coefficient, the measurement, the total error of the model. But for the multiple linear, to find the benefit, we need to calculate 3 things. First, we calculate the regression coefficient lead to the smaller overall model error. Second, we try to calculate statistics of the overall model. And third, we try to calculate the association of p-value. This is the end of my part. Move to my member.
Thank you, Panat. This part is about a summarized session. And I think that after you all guys listen about our presentation with each part, I think you guys will be still I'm not clear about it. So we are going to make a short and easy to understand about the summarized session. which we have three parts beside. The first part is about the linear regression. What is linear regression that we focus on? Linear regression is the way that we use statistic wave or measurement or the relationship between the variable or the value or variable that we got from the measurement that we use to study. And the next part is about the simple linear regression. In the simple linear regression, we use it with a dependent or independent variable or value that we got from the measurement that we use to determine or about some simple example that we first in the reality. And the last but not least is about the multi-linear regression. In this part, we focus about the outcoming or the expectation that we predict it with what it will be happen and which variable that we use. And this part also, if we want to predict something, we need to depend on the variable that we got from the measurement. Last but not least, here is the reference that our team member used to do a research and make us an understanding before we make a slide and a report. Thank you, teacher, and everyone.
Okay, so thank you for the presentation. And to our friend, do you have question? Let give a question. Anyone having question? So
May
I
I
will
have
point you.
question?
Okay. Kim Hain, yeah.
Because like I'm not catch up well, I want to know about what the difference between simple and multiple linear and the difference that we use the method on what case, like for the case.
So thank you for your question. And for the difference between the simple linear and the multiple linear is that the simple linear we have only two variables, which means is dependent and independent. But for the multiple linear, we use for the we have one dependent value, but we have a lot of independent values. So the difference is that for the simple linear regression, just only for two variables, and for the multiple, we have one dependent but with multiple independent values. And they have the same goal that they want to define the relation of those variables. They have a relation between each other or not, which also they can be have any error that consists in our calculation or in the relation of those variables like that. Thank you for your question.
Okay, do you get from the presenter, Kim Hain?
Yeah, teacher, I get it.
Okay. Any other question? As I mentioned, it's just like what your friend try to understand and then come up the presentation and share to you guys, because we are not cover all for those algorithms. Okay, can I have one more question? So yes. in what problem do we should we apply the multiple or single linear regression for the specific problem? Just give few examples.
Yes, thank you, teacher, for the question. For on the expression, in order to define what we're gonna use the simple and what we're gonna use the multiple, is that we need to define that have like I said before, we have how many dependent and independent variable that we have. And one more thing is that for the simple linear, they can be like have some certain of the value or the certain p-value they can be consistent. So in order that we have a minimal total error or any that, we use the simple linear. But for the multiple, we didn't know that how many independent value that can be consisting in the data, like present on his slide that we have two independent variables, which one is the ride bike and another one is the smoker, and the dependent is the heart disease. So in here we can see that we have two independent variables, but for my part on the simple linear regression we only have two variables, which the one is the dependent variable on the death number that we cannot change, and the independent variable is the population, which they can be increased or they can be a certain. So in here we can define which one is simple and which one is used multiple. So thank you, teacher.
Okay, I got that, but just give example on which problem. For example, last week we present we studied about the association rule algorithm, and this algorithm is likely to apply on the pattern of the transaction data. For example, like in the supermarket, so we are likely to use association algorithm. However, I just want to know, like, in which problem should we apply the single or multiple linear regression, which means that in which problem or in which topic should we apply the linear regression. Multiple or single is fine.
Let me make clear about this part. It's like that we can take the example when we go to the grocery store, we want to buy many things such like bulk, like meat, pepper, or another ingredient that used in the kitchen. So on that part we can consider it a variable. We use a lot of variable. So when we want to think about how can we support to buy all the things, so we use the multiple variable. But if we want to use the simple variable, it means that like we want only buy the one thing, it's like the closest in the close store. So we had a little bit money to buy it. So that in the case it depends on our ability to buy it only one thing at that time. So we use the simple regression. It's like that.
Okay. Thank you for the answer. It is not wrong, but just to make clear that for example, like if I want to predict, it's like we use linear regression to predict the value in the future, and it is based on the past data. However, we should use the linear regression or multiple or simple in the linear system, because we're gonna assume the data gonna be like linear, right? And one more thing is like when we predict on, for example, like we predict the land price for example, like in your example, from 1990 until 2020, this is the debt, right? This is the numbers of people gonna like die per year. So we're gonna like predict the land, for example, like the price of the land from year to year, it's gonna be increase or decrease. So something like that, we're gonna apply the linear regression. Okay, that's all what I want. And any other question? No? If no, yes, thank you for the presentation, and we can have like a 5-minute break, and then we're gonna come back to our course.
Thank you, teacher.
Thank you.
Oh, hi, teacher.
Hello. Yes.
Okay, right now question about tomorrow. Are we gonna exam tomorrow or no? 7 p.m. or we gonna have another question as well?
For the exam, I think we took only like 40 minutes, so we will have 2 more presentation. And yeah, I think it is on about the algorithm. For the introduction, I think I don't have much on the question. Just like one question maybe on the chapter 2, and the rest are the exercise on our algorithm. like what we have practiced in the classroom, in the session.
Thank you, teacher.
Okay.
Nó khổ mình say all program đấy nơi exam đang nó khổ.
Đôi chỉ ở sẽ ở thế còn là predict result ấy chẳng tôi tiếng chúng sẽ mà chui đấy vẫn còn là result ấy kia chẳng tới nhưng sẽ result tại nhưng đôi chỉ mình focus khá lên năng thế để sao tại program ở năng việc còn là chia thu mới để vẫn còn là ở giờ mình bachelor language năng mà thôi thế bữa sau bộ dương check Python nhưng mà Python của bạn bớt mẹ bộ dương research study không ai gì chẳng tới hay ở năng còn là chia alternative tool mới để class tiếp bởi vậy tất cả nhóm cả nhóm thư research nhóm ở mặt lab trong cái còn là chỉ alternative tool thế nhóm ở super thế trong vì chọn cứ lùm hát chứ vậy tới cứ miền 7 như miền gì gì nó miền came in rồi có KNN association rule mình trong committee cứ Navie Bayes today
ប៉ុន្តែក្នុងនោះមានសំណួរក្នុងប្រមាណដែរលោកគ្រូ
chỉ tới nhung bây giờ đặt tầm mũi thế sầm nô ở tràn thế toàn ấy còn tay ở chỗ bài tay kết phải chỉ tầm mũi thế giờ mới dùng nữa còn tay phía trên lồng hạt của tay lồng hạt vừa tăng kết bây giờ này chất thua lươn bay lồng hạt mà máu thua thao không được đâu chứ ở trăm mạch tự đặt sầm nô tràn này rồi nhá tay bây giờ đặt hạt tích hay chỉ sai sầm tí là thua lươn thua hào rồi nhá bảy hạt nó mà chỉ tới ở đấy thì don't worry just hay mini exam nhóm năng muốn nó cứ smart là quickly đang ngày để sao tại giờ tới timeline như vậy type page nhóm của bạn take break cho nhóm blog một đó này cứ smart là quickly đó
Course này thì trong trong mặt tập này là phục
bây giờ là shop được con dương bây giờ blog cho mấy khối kề mình tha dương blog lại hái à tật tìm môi down happy và nhóm blog ok right ហើយមេនយើងដូចជាចប់ទៅមេនទី6ហើយនៅសល់មួយ algorithm តិចគឺចប់ហើយហើយសល់ប៉ុន្មានគឺយើងខ្ញុំទុកពេលមួយអាទិត្យឲ្យពួកយើងធ្វើ mini project ហើយ mini project គឺពួកយើងបានធ្វើហើយតែខ្ញុំគិតគឺ apply project មួយមាន apply data set មួយទៅលើ algorithm មួយហើយទៅ share result ដូចគ្នាយើងអ្នកធ្វើ presentation ទី1អញ្ចឹងគឺគាត់ទៅ share result ឲ្យទាំងអស់ចឹងមកទៅធ្វើជា report ឲ្យខ្ញុំមួយមកគឺហើយមួយ group ម្ដងម្នាក់មួយ group submit មក report មក
គ្រូអញ្ចឹងដែរមែនលោកគ្រូ present មិញយើងចូលធ្វើ report ម្ដងទៀតមែន
និយាយរួម slide មិញហ្នឹង submit ឲ្យខ្ញុំមកបាច់ស្អីទៀតទេអត់ទេ
ដូច team ខ្ញុំធ្វើ report មួយធ្វើ slide មួយចឹង submit ទាំងពីរ submit
ទាំងពីរមកក៏បានអូខេតាមពិតខ្ញុំចង់ឲ្យពួកយើងសរសេរ summary ហ្នឹងនៅក្នុង slide ហ្នឹងហ្មងទៅសរសេរទាំងក្រុមហ្នឹងមកតោះណារើសជា algorithm សុំទៅរើស paper ណាមួយចឹងទៅ read ហើយបញ្យល់ថា paper ហ្នឹងគេ apply algorithm ហ្នឹងហើយយើង summary paper ហ្នឹងតិចមកចង់អញ្ចឹងវាតែប៉ុណ្្នឹងឯងjust time វាអត់សូវដូចជាអត់មានបាក់ទេសំខាន់ក៏យើងចំណាយពេល read ហើយធ្វើការ understand ដែរចង់អញ្ចឹងណា
គ្រូជួយឲ្យយកជា final ឬក៏លោកគ្រូមានជា final ផ្សេងលោកគ្រូ
យក slide ហ្នឹងមកគ្រាន់តែសរសេរ time summary បន្តិចទៅក៏បានដែរអូខេI'm speaking Khmer so it might be difficult for other students
teacher for our group we are the first group so we already implement the algorithm so we have to do it again
so the thing that you left is to write a report I will give you a format to write a report for me as the mini project so our mini project gonna be like you have to choose one algorithm one data set and apply those algorithms on the data set you want and apply like what I put the case study So the first step is data collection. Second step, clean data, prepare data, train data, result, evaluate result, improvement result. This is what you have to write in the report. Okay, and that's called the mini project. So if you have done it, it's fine, but just prepare the report. Okay. So I think we should move to the class now. Okay.
So we don't have another presentation about the project, right?
Yeah, you don't need to present. Just submit me a report.
Okay.
Teacher, how about the paper?
The paper? No, you summarize the paper in your slide presentation, right? And submit it to me. So you have to submit first.
Do I need to presentation? It? Okay.
So listen to me carefully. So after the presentation, you have to submit each topic for your presentation topic to my email, and including that you summarize your paper in there in that slide. And after that, I will introduce you another task is the mini projects. And in the mini project, you just apply the algorithm with the data set you want and write the step like the case study I present to you, right? The first step is like data collection. Second step like preparation data, the prepare data for train and mode and testing, train data, evaluation result, improve the model. So you just write on that 5 step. It's gonna be enough for the mini project, and you submit to me. That's all. And we wait for the final exam on the first week of February.
Thank you, teacher.
Yes.
លោកគ្រូញូ topic នោះមកក៏អា topic នេះលោកគ្រូ
I mean it's free topic. You want to choose any algorithm as you like. It doesn't matter. Okay. Okay.
យើងត្រូវទៅសេ program មានលេខវិភាសាផ្សេងណាលោកគ្រូ
Yeah, let me speak point a bit. ចង់ឲ្យថាកន្លែងនេះបើសិនជាយើងប្រើ Python យើងទៅសេ Python ទៅបើយើងតែបើសិនជាក្នុងមេខ្ញុំសច្ចេកពួកយើងប្រើ R ហើយតែបើសិនយើងថាយើងប្រើ R អត់ចេះយើងចេះ Python អូខេយើងធ្វើ Python ក៏បានប៉ុន្តែ capture step ដូចខ្ញុំធ្វើ case study ពួកយើងមើល case study ខ្ញុំមិនយក data អីមក prepare ខ្ញុំសរសេរ code តិចតួចដែរថាពេល run ហ្នឹងទៅចេញអីគេហើយហ្នឹង interpret របៀបមិនអីចឹងទៅអាហ្នឹងគឺរបៀបសរសេរ report ហើយហើយបើយើងយកតែ data ទៅទេមកដាក់តែ algorithm សរសេរតាមទ្រឹស្ដីខ្ញុំមើល report ហ្នឹងក៏វាអត់មើលទៅទៀតអូខេខ្ញុំអាចថាយល់បានប៉ុន្តែវាអត់ឃើញថាយើង apply ទេតោះវាពាក្យថាយើង apply មានថាយើងបានសរសេរ check មើលថាតើdata ហ្នឹងមានប្រមាណ record អីចឹងទៅដល់ពេលយើងកាត់ data នេះទៅ train អីចឹងទៅដែរដូចខ្ញុំដូចក្រុមទី1ធ្វើខ្ញុំឃើញដូចជាធ្វើបានហើយapply ចឹងប៉ុន្តែគាត់ថាទៅសេ report ឲ្យស្រួលតិចទៅរួចហើយ
លោកគ្រូចឹងខ្ញុំអាចប្រើ Python ឬក៏ភាសាផ្សេងក្រៅពី R ក៏បានដែរពេលធ្វើ mini project
អីខ្ញុំ open ឲ្យព្រោះអីក៏បានដែរ
អូខេអរគុណលោកគ្រូ
តែបើសិនជាប្រើ TensorFlow ដូចជាគាត់ដាក់ run ទៅចេញហ្មងហ្នឹងហើយពួកយើងអ្នកស៊ូមិនទៅណៃ
ចាលោកគ្រូ
ចង់ថាបើសិនយើងប្រើ TensorFlow អីចឹងណាអូខេតែអីដូចនិយាយខ្ញុំ open ឲ្យសំខាន់គឺសរសេរ report ខ្ញុំចង់ដឹងថាពួកយើង apply ចឹងទៅយើងសរសេរបានតែដោយសារពួកយើងភាគច្រើនសិតតែអ្នកធ្វើ research មួយចំនួនដែរអញ្ចឹងអូខេខ្ញុំឃើញការងារពួកយើងគឺល្អច្រើនចឹងអត់អីទេតែសំខាន់ complete final exam. Okay, so let's move to our course today. And
លោកគ្រូសុំកាត់មួយលោកគ្រូ
Okay, yeah.
ចុះចំណែកពួក M1 វិញមិនទៅលោកគ្រូ
topic ខ្ញុំ forget ចឹងមិន forget ទេតាមពិត topic ហ្នឹងគឺខ្ញុំនឹង random topic ពីគ្នាយើងពី e-sign ហ្នឹងដាក់ចូលឲ្យ អងយ៉ាងដែរអញ្ចឹងប្រហែលជាល្ងាចហ្នឹងខ្ញុំនឹងដាក់ចូលទៅក្នុង team ដាក់ចូលទៅក្នុង file sheet ហ្នឹងហើយនឹងពួកយើង ចាំខ្ញុំ inform ពួកយើងទៅពួកយើងគ្រាន់តែមើលលើ file ដែលគ្នាយើងស្ទាំងទៅគឺយើងដឹង topic អីគេហើយធ្វើដូចគ្នាអញ្ចឹងបងណាដោយសារតែ algorithm ផ្សេងៗទៀតវា too deep ពេកខ្ញុំគិតថាខ្ញុំ random នៅក្នុងចន្លោះគ្នាយើងដែល present ហើយហ្នឹងយើងក៏ present ដងទៀតទៅប៉ុន្តែអ្វីដែលសំខាន់ព្យាយាមរក paper ដែល different សម្រាប់ ណាអូខេ
ទៅពួកខ្ញុំមាន mini project មានត្រូវសរសេរ report ឲ្យលោកគ្រូដូចធម្មតា
ដូចគ្នាយើងធ្វើដូចគ្នាទាំងអស់អត់អីទេហើយ present នេះ present ដូចគ្នាទាំងអស់ចឹងទៅហើយខ្ញុំនឹងយក algorithm នៅក្នុងចំណោមគ្នាយើងដែល present ហ្នឹងមកដាក់ឲ្យពួកយើងវិញទេដោយសារតែ topic ផ្សេងៗវាជ្រៅពេកតែទៅមួយ deep learning អីចឹងចឹងខ្ញុំគិតថាប្រហែលជាដាក់ធម្មតាទាំងអស់ហ្នឹងទៅហើយឲ្យតែពួកយើង repeat មកវិញមកហើយរក research paper ណាដែល reference ឲ្យវាហ្នឹងកុំឲ្យដូចគ្នាឲ្យខុសគ្នាទៅដើម្បីយើងមក present ចែកគ្នាស្ដាប់អូខេ That's it okay so let's move to our course today. So today we are going to study about the Navie Bayes algorithm. So what is Navie Bayes? I think you guys might understand the Bayes theorem on the probability. So this algorithm is depend on the probability. So what is Navie Bayes? The Navie Bayes is a classification technique based on an assumption of independence between predictor, which is known as the Bayes theorem. The Navie Bayes algorithm describes a simple method to apply Bayes theorem to classify the problem. Although it is not the only machine learning method that utilize Bayesian method, but it is the more common one. So for the Bayesian theorem, there are many machine learning algorithms use that method. However, for the Navie Bayes, it's one of the common algorithms that use the Navie Bayes theorem, the Navie Bayes theorem. Okay, and the Navie Bayes application is like the most popular application. It is like the real-time classification, spam message filtering, also the text classification. So the strength and the weakness. So for the strength, it is simple, fast, and very effective. Does well with noisy and missing data. It requires relatively few examples for training, but also work well with very large numbers of examples. Easy to obtain the estimated probability for the prediction. But for the weakness, it relies on an often faulty assumption of equally important and independent features. So in this part, the weakness is that because the Navie Bayes algorithm having the assumptions that all the features should be independent. So that is why it might lead some erroriness to the prediction. Not deal with dataset with many numeric features. Estimated probability are less reliable than the predicted classes. So in this part, it is like that they have the theory that if you can predict the correct classes, the Navie Bayes doesn't care the probability on the predicted value on the predicted class. So this is what the Navie Bayes assumption. Okay, the Navie Bayes algorithm is named such because it makes some naive assumption about the data. In particular, Navie Bayes assumes that all the features in the dataset are equally important and independent. So that is why it is naive, because it assumes that all the features are independent and all important. These assumptions are rarely true in most real-world assumptions. For example, if you were attempting to identify spam by monitoring mail messages, so it is almost certainly true that some features will be more important than the others. For example, like the email sender may be more important than the email sender may be more important more important indicator because of spam. I mean, the email sender is more important than the message text, because if you know the sender, you might predict the email is it spam or not spam or harm. And if we don't know and if we compare to the feature message text, the email sender would having the priority, or maybe the confidence, maybe not the confidence, it's like the significant value that we can say is we can predict on the message, is it spam or harm. The Navie Bayes algorithm, additionally, the words in the message body are not independent from one another. This is because the appearance of some words is a very good indication that other words are also likely to appear. So, for example, a message with the word Viagra will probably also contain the word prescription or drug. However, in most cases, when these assumptions are violated, Navie Bayes still perform fairly well. So even there are some violations regarding the assumption, the Navie Bayes algorithm still perform better. This is true when even in extreme circumstances where strong dependency are found among the features. So these are the Navie Bayes assumption, and also the reason why they give the name on the Navie Bayes. Okay. So here, classification with Navie Bayes, understanding probability. So from this side, suppose that we have an old email, coming email, that we can say 20% are spam and 80% are harm. So the circle represents the 20% probability that the message is spam. The remaining 80% represent the complement of P spam. So this one, it should be the P not spam. P not spam refer to the probability of not spam equal to probability of harm, right? But we put the minus here. Here. So this is the data we have, and also the proportion. And if we look at into this diagram, we're gonna see like we're gonna have like the message spam, also harm, and we have the Viagra here. So what does it say? We would like to quantify the degree of overlap between these two proportions. The Viagra and the two proportion is the Viagra in spam and also the Viagra appearing in harm. In other words, we hope to estimate the probability of both P spam and P Viagra occur, so that this can be written as P spam intersect Viagra. The symbol intersects. So this is intersect, signifying the intersection of the two events. Hence, the notation of A intersect B refer to the event in which both A and B occur. So in this part, just represent like the joint probability. And when we see like the Viagra here, we can say that this proportion, this part, if we zoom in, would be the Viagra appearing in harm. So it's like the email harm message containing Viagra text. Or here, you can say that it is the spam without Viagra, and also with here, the Viagra in spam. Okay. The relationship between dependent event can be described using Bayesian theorem, as shown in the following formula. So I believe that you guys gonna understand most of this stuff already from your year 4, year 5, year 3, I think. And just rewind it back. So this is like the Bayesian theorem. This is like, it's a probabilities of even A given B equal to probability of A intersect with B, even A intersect with B over the probability of B. So this is the conditional probability. So I'm gonna move next. Bayes' theorem tells us that our estimate of P A given B should be based on the probability of A intersect of B, a measure of how often A and B are observed to occur together. So probability of B measures of how often B is observed to occur in general. Bayes' theorem states that the best estimate of probability of A given B is the proportion of a trial in which A occur with B out of all in the trial of all trial in which B occur. So from that, this is what we deriving and what the assumption. By the definition, we have the probability of A intersect with B equal to this one. So from the deriving that algebra, we can get this one. Okay. So this is probabilities of A given B equal to probability of B given A multiplied by probabilities of A over probabilities of B. Right. So here, so if we're concerning back to what we want to measure on the spam message, if we want to find the probability of spam given the text message Viagra would be equal to the probabilities of Viagra given the spam multiplied by spam and divided by probabilities of Viagra. And this probability would call the posterior probability, and this is the likelihood, and this is the prior probability, and this is the marginal likelihood. All right. So go back to example. We construct a frequency table. Construct a frequency table that record the numbers of time Viagra appear in spam and ham message. So this is we construct a frequency. It is like this. This is the probabilities of spam given Viagra equal yes equal 4. But we count it as a frequency. This is the frequency of message is spam given Viagra is true or is yes, and this is the frequency of the message spam given Viagra equal no. Okay, so continue to that. We have the frequency. After having the frequency, we can construct a likelihood table, which is here that you can say that the likelihood of the message is spam given the Viagra equal yes equal to the 4/20. All right. So how can we check that? This is just what we constructed, just an example, and so on. All right. The likelihood table revealed that the probabilities of Viagra equal yes given spam equal to 4/20 is equal to 0.20. This indicates that the probability is 20% that a message containing the term Viagra, given that the message is spam. Okay. Additionally, since we have this one, we can calculate this probability. All right. So we just place the value in here, and then we got this. All right. So classification with Navie Bayes. Let's extend the spam filter by adding a few additional terms to be monitored. In addition to the term Viagra, money, grocery, and unsubscribe. Okay. The Navie Bayes learner is trained by constructing a likelihood table for the appearance of these 4 words. And for example, we just label the W1 refer to the Viagra, the W2 equal to the money, W3 is the grocery, and W4 is the unsubscribe, right? As shown in the following table. So here we just extend it to the 4 feature, add 4 more features and giving the likelihood table. So this is the likelihood table. So as I have read it, we can say that this is the spam likelihood. We can say that the message R span given Viagra equal yes is 4/20 here, and so on, right? So these are the likelihood table that we have. So as a new message I receive, we need to calculate the posterior probability to determine whether they are more likely to be spam or harm, given the likelihood of the words found in the message text. So for example, I give a new unseen data or a new message coming, which is containing the term Viagra and unsubscribe, but does not contain either word money or grocery, right? So based on this example, we can say it's like this. Thus, we are interested in finding the posterior probabilities of probability of spam, given that this is the W1 here is referred to the Viagra yes, with Viagra yes intersect with the unsubscribable. Unsubscribable refer to this is subscribe, right? Right. So it should be. Oh, this one should be not minus. But it's fine. Just example. Let's say that the W1 here is referred to the term Viagra given. Sorry, the spam message given the Viagra equal yes, and this one is like the message spam given that the unsubscribe equal no. So that means the posterior probability should be the P spam given W1 intersect not W2 intersect not W3 and intersect with W4. Okay. Oh, I think it is correct. Sorry, because W2 here we refer to the money, and the money is not. So not contain either the word money. So this is not money, and this is not grocery, but unsubscribable yes. Okay. Yes, Suma.
កន្លែងហ្នឹងដែលថាយើងដាក់ប្រចាំវាហ្នឹងយើងយកយើងព្រោះអីនៅក្នុងហ្នឹងវាមាន yes ផង no ផងអញ្ចឹងយើងយកមួយណាឬក៏យើងដាក់ម្ដង yes ម្ដង no ទាំងអស់អញ្ចឹងណា
No នេះគឺ based លើ example គេនេះ example នេះមានថាម៉េចខ្ញុំចង់គេថាខ្ញុំមាន message មកមួយនេះគឺជា message ចាស់ដែលខ្ញុំមានទាំងអស់តោះ message ចាស់ខ្ញុំមាន likelihood table ហើយតោះនេះចឹងដល់ពេលនេះ message ថ្មីខ្ញុំមកដែល message ខ្ញុំហ្នឹងគឺវា contain ពាក្យ Viagra ហ្នឹង yes and no សំណួរគេចង់ស្គាល់ថាវា yes yeah contain the term Viagra បើវា contain មានថាវា yes okay and unsubscribe វាគាត់ជា yes ដែរប៉ុន្តែខ្ញុំច្រឡំ W2 វិញគឺដោយសារតែស្មានតែយើងតាំង W2 ហ្នឹងជា unsubscribable តាមពិត W2 ហ្នឹងគឺសំដៅទៅលើ money ឯង W4 បានវាសំដៅទៅលើ unsubscribable unsubscribe អញ្ចឹងដល់ពេលហើយបានយើងត្រូវរក probability នៃ spam given that feature 1 intersect feature 2តែ feature 2យើងគេ money តែគេវាថាវាអត់ contain money អញ្ចឹង not money អញ្ចឹងយើងមាន not money នេះ not money អញ្ចឹង not money ហ្នឹងបានយើងនិយាយថាម៉ាត់បើសិនយើងរក probability គឺយើងរក money given no ឃើញទេឃើញមកខ្ញុំ scroll ដាក់ពីលើទេពួកយើង yeah so that's why we what we have to calculate based on the example we give, right? So this is the posterior probability that we would like to calculate or to find. The formula which captures such posterior probability that a message is spam, given that Viagra equals yes, money equals no, grocery equals no, and unsubscribable equals yes, if given by. So this is the probability that we get based on what we the formula we got from the Bayesian theorem. Okay, so this is the formula here. So I put it the same here. For a number of reasons, this formula is computationally difficult to solve. The work becomes much easier if we can explore the facts that the Navie Bayes assume independent among events. So conditional independent allow us to simplify the formula using the probability rule for independent event, which state that. So based on the Navie Bayes assumption, it is independent among events. So we can simplify our formula into this way. Probabilities of A intersect of B equal to PA multiplied by PB. So from that, we can simplify our formula here to the proportional here. Because the denominator does not depend on the class, spam or ham, so it is treated as a constant value and can be ignored for the time being. This means that the conditional probability can be expressed as. So based on that, our new formula gonna be this one. The probabilities of spam given what we are interested, proportional with the probabilities of W1 given spam multiplied by probabilities of W2 not W2 given spam, and so on until multiplied by the probabilities of spam. And the probability that the message is ham can be expressed as here. So this is the spam and this is the ham. So in order to judge that the new message is spam or ham, you have to calculate both posterior probability. And then you have to compare which value gonna be bigger. If the P spam, the posterior probabilities of spam is higher than the probabilities of message is ham, so we can judge that, or we can classify that the new message is a spam message. Okay. Using the value in the likelihood table, then we can start filling numbers in this question. However, to convert the numbers into probabilities, we need to perform one last step to reintroduce the denominator that we had been excluded. So the last thing that we have to do, just like convert back to its original probability. So just come back here. Essentially, we must rescale the likelihood of each outcome by dividing it by the total likelihood across all possible outcomes. So here, what we want to find, and this is how to convert it. So we have to calculate the value of the P spam and the P ham here. And if you want to convert it back, you just apply the formula. The P spam given the T here refer to the target or what we want, what we like to find. P spam given this proportion, P spam given that W1 intersect not W2, intersect not W3, and intersect W4 equal to the value that you calculate from the likelihood, P spam here plus with ham. So we're gonna convert it to the probability value. And also the P ham also the same thing. After you compute that two value, you can compare it. And if which one is bigger, the class, the new message or the incoming data are gonna be into that class. Okay, so the V here represents the value computed from the likelihood table based on the Bayes theorem. So the value V here, I just put it here, refer to the value that you calculate from here. Okay, calculate from this value, and you just convert it back by put it into this equation. So the step in the Navie Bayes algorithm. Step 1, you have to construct a frequency table based on the data set. Step 2, construct a likelihood table that I have mentioned to you. This is the likelihood table. And 3, find the corresponding conditional probability and multiply them according to the Navie Bayes rule. And then divide the total likelihood to transform each class likelihood into the probability. So this is how you transform the likelihood, the value of the likelihood class you calculate it. So after that, you just compare the value, and then you can see which class should the new data in. So it's coming to the final summary here, but I won't summary it yet. Do you have any question first? If not, let's see the example here. Okay, so find the probability of spam and ham by using the likelihood table and convert it to probability. Do any other? I mean, does anyone understand how to do it based on the formula here? Based on here? No.
No, teacher.
If not, let me try to do it. Text editor. So this is might be not the correct one. Just show you how to calculate it. So you have to understand first the probability that the posterior probability that you have to find, and then it would be in this formula, right? So right now, let me move to here. Oh, sorry, I just write this back again. Actually, in this IDE, I cannot write the syntax for the intersect. So I just write like, this is what we are interested to find, P span, right? Given that W1 intersect, I put the word int here instead of the intersect sign. Not is just minus W2 intersect with the not W3, and also intersect with the W4. So this is the posterior probability that we would like to find, equal to the probability of W1 given span. Okay, this is multiplied by probability of not W2 given span, right? Multiplied by P probabilities of not W3 given message span, right? And the last one is multiplied by probability of the W4 given span. No, the last one is here. Probability of the span, right? Here. So this is what we want to find, right? Okay, this is the posterior probability we want to find. So now we go back to see from this, right? So probability of W1 given span, what is its value? So I can put it to equal. Okay, equal what? Probabilities of W1 given span. W1, what is W1? W1 is the Viagra, yes, right? So it is here. The probabilities of Viagra, yes, given it is span, 4/20, right? Is it correct?
Yes.
Multiplied by probabilities of not W2 given span. Not W2, what is W2? This one, right? So probabilities of not money given no. This is given no with the message span, 10/20, right? This one. This is message span, and this is the money is for no, right? So it's gonna be like 10/20, right? Is that correct?
Yes.
Yeah. So just continue like this, and this is the probabilities of the not W3 given span. Not W3 gonna be like not here, and spam is here, so gonna be 20/20. Gonna be 1, right? Just put 1. And multiply by the probabilities of W4 given span. W4, yes. W4, not W. This is W4 equal yes. So here, and given span is here, so gonna be 12/20. Okay. And the last one, we have to calculate the probability of span. So how many span do we have? it's gonna be 20 over 100, right? This is 20, sperm we have 20, and the total record gonna be like 100, so it's gonna be like the 20 over 100, right? The probability of P sperm.
Yes.
Probability of message is spam. We have 100 message, 20 is spam. 20 is are spam and 80 are ham. So what is the probability of P spam? It's gonna be 20 over 100, right? So you can calculate that. I think it's not much difficult. Just the definition is quite hard to understand, right? So anyone can compute for me, right? This one is 1 over 5, right? Multiplied by 1 over 2, right? Multiplied by 1, I don't need to put it. 12, 6, 2, 4, yeah. Gonna be like 3
over 4,
5,
3 over 5.
yeah, and multiplied by 1 over 5, right? That's correct. So how much do we get?
We got 3 over 2 and 4 50.
Again, please.
3 over 2, 50.
Can you put it into the float number? How many? How much?
That would be 0.012.
0.012, right? Yeah, okay. So now this is the posterior probability given the message is spam. So from this probability, we cannot check that our new message is spam or ham. So we have to calculate again, right? This one, it should be ham, right? So I think it's gonna be quite the same. Just the value gonna be different, right? This is ham, so it's gonna be like this. The same thing. Just this one is ham. Oh, select only one. Ham. 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 Yes. This one is ham. So this one is also ham, right? So what is the probabilities of Viagra equal yes and message equal ham? Message is ham, sorry. So Viagra yes and ham 1 over 20. Sorry, 1 over 80. Like this. And multiply by probabilities of not money given ham, no money given ham, 66 over 80. 66 over 80, right? And multiply by not W3, not grocery, and given ham, not grocery and given ham, a 71 over 80, 71 over 80, right? And multiply by the PW4, probability of unsubscribe equal yes given ham. This is yes, yes. So 23 over 80. 23 over 80, right? And multiply by probabilities of ham. It should be 80 over 100, right? So what is the result? How much, guys? Can you compute it?
I'm not sure. 0.0021.
0.021. Just only 2, I think, because we take only 3 digits, right? We can round it up that. So right now, come back to our lesson. So right now you have computed the probabilities of spam and also ham. So right now, just the values, just the likelihood. So right now we have to convert it back. To convert back, it's just here. The P, so we'll just put like the P spam like this. spam. I just put the given as t, the target one, equal to like v spam given t should be 0.0012 divided by 0.012 multiple by not multiple plus with 0.002. So what is the result? Just do like this. So you're gonna get the result here, and also the p ham given the target.
P spam is equal 0.857.
0.857.
857 8
Okay, wait. And piece of ham should be 0.002 divided by 0.002 not multiply, it's just sum with the 0.012. So what the result?
0.14.
0.14. So this is the probability, right? So which one is higher? It should be this one, right? So we can state that the message is spam based on the result we get. This one is bigger than this one. All right. So this is how you classify a new coming message based on the likelihood we had. However, to construct a likelihood, you have to understand the probability and create a frequency table, and also create the likelihood table. After you create a likelihood table, you can compute the posterior probability here, and you can predict the class for the new message or the new coming data. Okay, so that is all for the Navie Bayes algorithm. So do you have any more question on that? Yeah.
ខ្ញុំចង់សួរថារូបមន្ត farm មួយហាន់ណាអាហ្នឹងក្នុងករណីដែលយើងប្រើ eBay ហ្នឹងมันយើងអាចសន្មតថាវាស្មើរូបមន្តប៉ុណ្ណឹងមែនលោកគ្រូ
តាមពិតមិនស្មើហ្នឹងគេហៅថាវាជា proportional សញ្ញា proportional វាជា proportional ហើយ proportional គឺដោយសារតែយើងនិយាយថា Navie Bayes ហ្នឹងវា naive ដោយសារតែវា make assumption ថា independent among events អញ្ចឹង independent among events យើងអាច compute វាចេញបានប៉ុណ្ណឹងណាបើសិនយើងគណនាវាអញ្ចេះគឺមិនដឹងគណនាមួយទេនេះជាប់ច្រើនត្រូវអត់អញ្ចឹងយើងស្វេវាដាច់ហើយនិយាយទៅដូចគេនិយាយអញ្ចឹងក្នុង algorithm ហ្នឹងគឺវាមិនប្រកាសថា 100% ប៉ុន្តែវាអាចចាត់ទុកថាវាអាច apply សម្រាប់ application មួយចំនួនបានអត់ទេ
អរគុណលោក
លោកគ្រូសុំលោកគ្រូ algorithm ហ្នឹងយើងប្រើដើម្បីនឹងប្រើនៅពេលណាលោកគ្រូ
invent វានៅពេលណាដូចខ្ញុំ give example នៅលើនេះអញ្ចឹងនៅពេលដែលយើងប្រើនេះ real time classification spam filtering text classification ខ្ញុំឧទាហរណ៍3នេះមិនមែនមានថាមាន13ណាខ្ញុំឧទាហរណ៍ដូចជាយើងចង់ធ្វើ net traffic classification filtering ខ្ញុំគិតថាដូចជាធ្លាប់មានអ្នកណានិយាយពីរឿង Navie Bayes apply លើ traffic filtering ហ្នឹងនៅពេលដែលមាន incoming message ណាដែលវា abnormal អញ្ចឹងគេអាចប្រើ Navie Bayes algorithm ដែរព្រោះតែវា apply ជាមួយ text classification នេះបានអញ្ចឹងនៅពេលដែលមាន message coming អីហ្នឹងតាក់ទងជាមួយ text គឺក៏ language គឺ Navie Bayes អាច apply បានប៉ុន្តែនៅក្នុង algorithm របស់វាត្រូវការ language processing មួយទៀតព្រោះតែពេលខ្លះកាលណាយើង focus លើ text របស់យើងខ្លះអក្សរយើងខ្លះវាមាន special character អញ្ចឹងយើងត្រូវ remove special character ដើម្បី remove ហ្នឹងគេប្រើ language processing មួយចំនួនអូខេនៅពេលដែល apply វាមែនតើណាដូចយើង normalize data អញ្ចឹង clean data អញ្ចឹងសិនអូខេ Okay, I have one more thing to show, just a little bit. So actually, I want to show you this problem to give you an example, but since we don't have much time, I just give you here. So this is our sample data set. Okay. For example, like this is the data set we had, and what we want to find is that should today I go to play tennis or to play golf or not. So given that today, this is the broadcast of the today. Like today, outlook is equal sunny, temperatures hot, humidity is normal, windy is fall. So this is like today broadcast, and this is the previous data I had. So I would like to predict should I go to play golf today or not, because if the weather today is not good, I cannot play golf, right? This is the example, and here, as I also write example here, so this is the probability that the posterior probability that we would like to find both yes and no, right? And then we compare like I had done for you. So in order to do that, the first thing you have to create a frequency table. So the frequency table, how should you construct it? Maybe I think you might try to search it a bit, because it's gonna be like an exam tomorrow. And also how to construct a frequency likelihood table. So I can show you a little bit from here. To construct a frequency here, for example, you see this is the frequency table, and this is our data. From the example, I don't give you the full data, I just give you the frequency. So if we look from the data, we just count like this. We have feature outlook, right? This is outlook. So this is Viagra. So I put outlook here, and we had class here, yes and no, right? So our class gonna be play equal yes or play equal no, right? Play equal yes and play equal no. So let's look at the feature. This is Viagra and yes. So let's look on the feature outlook. We have outlook and rainy. So rainy here given class equal no. How much? How many? 1, 2, 3, and yeah, only 3. So which means that we have the outlook given rainy equal 3. Class equal no 3. So no equals 3 for rainy, right? And for the yes, how many? 1, 2, right? So this is how you count the frequency and construct a frequency table, right? So do you get what I mean, guys? I can show you one more. The LibreOffice. Okay, I can construct for you here. Oh, so small. So let's say like we put like this, the same thing. We just put like this is outlook, and this is like the just put like here frequency. This is free. I just put like frequency, and this is like we put the class. Our class has two class, play equal yes and play equal no, right? And this is the total we had. And in the outlook we had how many features different? Rainy, overcast, sunny, rainy, overcast, sunny. So we have rainy, overcast, and sunny, right? So this is our outlook. How can I merge it? Merge. Yeah, just put it there. So let's count the rainy. Outlook rainy given class equal yes. Outlook rainy given class equal yes. Rainy no, rainy no, rainy no, rainy no, rainy yes 1, Rennie yes 2 and finish. So which means that the Rennie, the outlook equal Rennie given the class equal yes equal 2, right? And for no equal 3. Rennie no 1, Rennie no 2, Rennie no 3. This is row 3, right? Overcast. Overcast given class outlook equal overcast given class equal yes. Overcast here, overcast, where, overcast here, yes 1, yes 2, yes 3, and yes 4. So which means equal 4, right? So do you guys get what I mean now? Hello guys?
Teacher, so here you take only one attribute, I mean a feature of one attribute because
Yeah, this is one, because we in the example we have only diagram. I just give example, right? But our example we have outlook, temperatures, humidity, and windy, 4 different features. So you have to construct the frequency table for outlook and also the likelihood, right? This is like likelihood for outlook 2, right? Right? This is outlook as okay, right? And the same thing. So how many? You have to construct it like this. And also you have to construct the frequency for the temperature, right? Temperatures like this. Play equal yes, play equal no. How much? How many? Sorry. So this is how you read from the data and construct into the frequency table and construct it into the likelihood table. And for example, for likelihood, this is rainy, right? So how many yes for the total data we had? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the likelihood should be 2/9, right? Sorry, this one given me like this. Here 2/9. Okay, right? How about no? So we have total data is 14, so I think it should be 3/5, right? And here 3/5. Oh, sorry, wrong plot. It should be right here.
9 លើ 14
Okay.
អានោះដាក់7លើ 9 និង3លើ 5 វិញចឹងមែន 9លើ 14 នេះហ៎
This one should be 3/5 and the total should be 5/. This one should be 5/14. You can think on it a bit. It is like the probability we had, right? So outlook equal rainy given yes. How many yes you have? 9, right? This is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is no. How many no you have? 1, 2, 3, 4. Sorry, this one is 4. 4, 5. 1, 2, 3, 4, 5. Yeah, 5. That's correct. So this is how you create the frequency and the likelihood. If you can do it correctly, your calculation for the prediction should be good. Okay, thank you for the class today and see you tomorrow morning. And tomorrow morning, we're gonna have 2 sessions the same as today. The presentation and the last session is just the mini exam. And I think I focus on the algorithm mostly. I don't focus on the question much. So just focus on the algorithm that we had learned, KNN, K-mean, association rule, and Navie Bayes. Okay.
Teacher, please pause.
Right. Yes. Question.
Please pause the
lesson.
The lesson. Yeah.
Okay. I will send it to the team. Fine.
លោកគ្រូខ្ញុំសុំសួរមួយលោកគ្រូចំពោះ report ហ្នឹងពួកយើងសេពរៀងខ្លួនឬមកក៏យើងសេពជាក្រុមលោកគ្រូ
សេពជាក្រុមទៅការងារហ្នឹងអត់អីទេពួកយើងសរសេរជាក្រុមមកសំខាន់ខ្ញុំនិយាយចំចិត្តទៅបើសិនជាពួកយើងធ្វើការជាក្រុមខ្ញុំជឿថាមានអ្នកអត់ទៅធ្វើនិងមានអ្នកធ្វើច្រើន អ្នកធ្វើច្រើនក៏មានអ្នកអត់ធ្វើក៏មានប៉ុន្តែដូចនិយាយអញ្ចឹងមេរៀនខ្ញុំពីលក្ខណៈជាមេរៀនយើងរៀនដូច research ខ្លួនឯងអញ្ចឹងវាអត់មានតតែយើងចេះ skill អីមួយខ្លាំងឯងប៉ុន្តែអ្នកណាដែលខំគឺគាត់ចេះច្រើនហើយអ្វីដែលសំខាន់គឺពេលប្រឡងខ្ញុំឲ្យបន្ទុកលើការប្រឡងខ្លាំងអញ្ចឹងបើសិនជាលំហាត់ធ្វើអត់ចេញអាហ្នឹងខ្ញុំអាចជួយបានទេនិយាយចំគឺតែប៉ុណ្ណឹងអញ្ចឹងតើតើនឹង assignment នេះដូចជាជួយឲ្យជាប់ទេប៉ុន្តែបន្ទុកចង់បានខ្ពស់តអ្នកណាខំ Okay, this is chapter 5 and uploaded. Yes, I already uploaded the chapter 5 into the Microsoft Teams, so you can check on it. For this example, you don't need it. It's fine. I think it's fine. Just example, and this is how I just show you on how to construct the frequency table and the likelihood table. Okay. Okay, that's it. Thank you for the class today. Thank you, everyone. See you tomorrow morning.
Thank you,
Bye,
sir.
teacher.
Bye, sir.
Yes.
Goodbye, teacher.
Goodbye.
Thank you, teacher.